Alright. Good morning, everyone. Can you hear me?
Yes, teacher.
Good. So, all of you, can you type your name and class into the chat box?
Okay, miss.
So, I have to take the attendance. Name and class, both. Okay. Right. All right. Can you see my screen?
Yeah, miss.
Okay.
Yes, miss. Yes.
Yes. Yes, I see that. Yes,
Okay.
miss.
So,
Yes.
in this meeting, I have a 40-minute time limit. So if we exceed that, maybe you will be disconnected from the meeting. So if it happens, you can again join, right? Quickly join again, right?
Okay.
Okay. So here today, I hope 6A, 6B both are here. Our lesson is decomposing problems, creating a smart solution. So this is our lesson. At the end of the lesson, we have to create a smart solution, right? First, we have to understand software and hardware, right? You don't have to write anything now. I will share this note and you can later write that, right? So first we have to understand software and hardware. Hardware is a hardware is a physical part of a computer. If we can touch, then it is hardware. Like the monitor, keyboard, and even the parts inside the computer. Also, there are parts we can touch, no? Like CPU. So that is also a hardware. And software is the programs or set of instructions we run in our computer. The software tell the hardware what to do. Means software is the one who instruct hardware to work. But the computers need both hardware and software to function. Like we hardware and software need each other, right? And there are two types of software, right? Two types of software, system software and application software. System software means they are the software we can use to make sure the computer can operate with. Example is operating system in your computers also. Maybe you have Windows operating system or Mac OS in Apple MacBooks, right? So there are many other operating systems as well, but the most famous one is Windows. So this is a operating system. This one manage the hardware and software of the computer, right? So it is a system software because system software we use them to make sure the computer is operating well, right? So that is one type of software, and the other type is application software. It means we use those softwares to some specific tasks, like let's say the Google Chrome web browser that is specific for searching data, and Microsoft Word is also specific for uh, the documentation work, and Scratch is also a specific programming tool which we can do programs. With Scratch we can type documents, right? Like that, those are for specific tasks. And among these application software, some are like general purpose. That means those are specific, but that can be used for various range of tasks. Like the example is Microsoft Word, the best example. It is a specific application software for documents, but it is a general purpose. they can be used for various tasks. It means we can type the documents and edit the documents. We can we can create another documents like invitation cards, let's say assignments, notes, like that. It's a general purpose one, right? And some application software are very specific those are designed for only for a particular task, right? Have you heard of simulator softwares? Simulator means we are creating a physical device inside our computer to test that. There's an example called flight simulator, right? Like that. Also, we have some other simulator softwares. Here also in today's lesson, we have to use one of simulator softwares. It means we create some physical device inside our computer and test that without doing anything with the real physical device. So those are very specific tasks. So those kind of softwares are also a specific application softwares, right? And also you have to know how computers understand instructions. The CPU, central processing unit, is the one who take the process the inputs and give us output. No, so the CPU can only carry out instructions in binary. It means in ones or zeros. Only in ones or zeros CPU can work. So all the software instructions, all the softwares must be translated into the binary form for CPU to process, right? So do you have any questions up to this point?
No.
No.
No, miss.
Right.
No, miss.
And let's move on to microbit. So microbit is it's actually a practical lesson. Microbit is it's like a small board which we can use for programming, and we can actually see the outputs, right? So this is a physical computing device, which means a hardware, a physical computing device mostly used for education purposes. Now you are in grade 6 now, you are new to programming. So the microbit is a best device you can learn about programming, right? In microbit, there are many inputs like buttons, there are sensors, and also a mic. And also there in the microbit board, there's output, like there's a digital display and a buzzer, right? And the microbit can be programmed using the make code simulator, which allows testing programs before running them on the actual device. Here, this is the simulator I told you earlier, make code simulator. This simulator, we can use this for testing this microbit board, right? So I will show you, this is the simulator, right? This is the make code simulator, right? In this make code simulator, here we can have an image of the microbit board. Microbit board is like this. I will show you a image here. Here, can you see this is a microbit board? This is the one we are talking about. So this device, like without doing anything with the physical device, we can simulate it using this one. So here it is, right? Here we have inputs like buttons, and here some other buttons, and here we have the display, right? So first we are going to use this simulator to test the programs on this microbit board, right? Without doing with actual device. But if you have this device, or if you get the chance to buy the board, you can test this, but it's not necessary, right? So it's kind of expensive, no? Right. Here, programming in make code. So the make code is also a block-based programming environment. Here, can you see? This is a block-based environment. This is like in Scratch. In Scratch also you have these kind of blocks now. So here, this is also a block-based programming language. In this microbit, make code simulator, right? And also in the make code simulator, you can have the Python code as well, like this. Here we can see the relevant Python code for this block. But this Python language is called MicroPython. MicroPython because this is specifically designed for this microbit simulator, right? So this one is very specific for this simulator. So we call it MicroPython. When we work with the microbit, we have to use MicroPython, right? Here in this make code software, this one, you can see the blocks, which means block-based and text-based, like this, both like this. Here, if we see an example, here can you see this flow chart? Here we have, this is an example program we can test on the make code, right? Here this is start, and then it asks is button A pressed, and if yes, display hello and then display a happy face, right? And then again come to the starting point and ask the question. So it always asks the question, is the button A pressed? And if it is pressed, we have to execute these two steps. And no, if not, then again go to the start and again ask the question. If not, we don't have to do anything, right? Here in make code blocks, this is how we can represent this. Here, first we have to take a loop kind of thing on button A pressed. This is the one for this decision. And then inside the yes path, we have to know. So here we have to put those two blocks inside this block. So it means we are executing these two steps if the button A is pressed. Show hello and show the icon smile face. Here in MicroPython also, this one is represented as on button press A and basic.show string hello and basic.show icon names dot happy. So this smile face icon is called as happy. So we have to type happy here, and then we can have this last line, and then the same thing happens. The program will work in the blocks or in text like this. Here, let's see how it works. Right? Here we have the same blocks here on button A pressed. We have to we could change this as well and show a string. I have typed hello here, and you can type anything here, right? Show icon smile face. So there are many icons, right? There are heart icon and tick and cross like that. Many icons are there. But in this question, we have to show smile face. So here, let's see one button if pressed. I press the button, and can you see in the screen, the hello is displayed, and here the smile face, right? Right. So what if I press B? Nothing will happen, right? This is the last thing we displayed when we press A. But if we press B, this hello part will not work. Right? If we restart this one, right? So there's nothing here now. So if we press B, nothing will happen because we have programmed it to work only if we press A. So tell me, you understood this part, this block and the simulator working?
Yes, miss.
Clear?
Yes.
Yes.
Right. Here, we have many blocks like this, right? You can go to this site, makecode. You can just search on the Google, make code, MAKECODE, and then you could like come to this interface, and you can do your like programs. You can do whatever the programs and test this. Like there's no like a specific way to do this. Like it's up to you. I mean, you have to go to this website and you have to test and practice and observe, right? You can do anything here. And just we have to get the understanding of this. This is a very small program. You can do large programs with all these blocks, right? Here, this part we discussed now. And this is a simulator. This is a simulator. So if we have an actual microbit board, we can we can put this program into that one to work. We call it as downloading. We can download the program. Here, if we click download, uh, here connect your microbit to your computer. So we have to connect our actual physical microbit to the computer using USB. Right? Next, we can download this code into the board, and then we can actually see the hello and smile face here. I don't have an actual microbit, so I can't continue here, but this is the way you can do it, right? But here we have used mostly the make code is this one is used for the blocks, right? But for use this with MicroPython means in text-based language, we have to use another software called microbit python.microbit. Here, this is the microbit Python environment. It means MicroPython environment. Right? Here, to fully utilize MicroPython with the physical microbit device, coding in the MicroPython environment online is required. Right? This is also you can access with a web browser. Here also you have a simulator. Here also you have a simulator. But this is mainly used for coding. We can type our code here and then we can type our code here and we can send it to our board and see how it actually works, right? So the main difference between these two are here we have blocks, right? Here we don't have blocks, we have to type the code. We have to type the code in my MicroPython language, right? The simulator is there for both, right? But the make code, this one is the first thing you have to use. This is the most like the starting thing. You can start with this one, and if you're familiar with the blocks, then you can go into MicroPython language here, right? Here also the same things are here. You can use this. Try. And here in the note, we have how to send the code to the microbit device in MicroPython. Uh, just we have to type the code and send to microbit and do the same thing here, right? Here you have the steps. You can later read these things. And this is another special thing we have to know. The MicroPython, if we write a MicroPython code here and we are sending the code file to the microbit board now. So that code file has two formats. That has .hex file format and .py file format. the .hcx means these are only understandable by the microbit, right? We can't understand these files. And .py file is a Python file, and this one we can open the Python file notepad and we can read the code, right? So those are two file formats. And in a MicroPython file, right? Python file, we have to first import this library before coding from microbit import and star. From microbit import star, right? Here this imports all the functions we can use for microbit. Here the star means we are importing all the functions. The library, simply a library means this is not an actual library where we can read books. The library here means it's a set of functions, set of inbuilt functions, inbuilt Python functions. So we have to use we can't use the Python functions without importing this one. Let's say, how about the command, like we know some functions like print, help. Those functions we don't need libraries. The microbit functions we need libraries. So we have to import this one and then we can use the function names. You will see those when we actually do practicals. Just have the understanding of this library. Right. Now tell me if you are clear.
Yes.
Clear?
Yes, miss.
Yes,
Ah.
miss.
Yes, miss. Yes, miss.
All right. Here, now we are going to talk about the sensors of this microbit board. Right? In this microbit, I told you there are inputs and outputs. One output you saw. The display is one output, and the buttons are inputs, and sensors are also inputs. There are sensors, right? So we can use this microbit board to collect the data from the environment and do some program and make a output, right? Here, this microbit version 2, that includes these sensors. Touch sensor. This touch sensor is in the logo of the board, the top of the board, and temperature sensor, sound sensor, movement sensor, light sensor. Those sensors are there, and this is how we code about the sensor. Right? This is the code line we use if we have to do anything with sensor, right? And let's say example, to protect the microbit, you can use the touch sensor on the logo. If the logo is touched, it can trigger a specific action such as sounding an alarm. Like that, we can do those kind of things, right? And the sensor data here, the microbit board collect the sensor data and those are converted into integers, right? Because those are numbers, so those sensor data is automatically set as integers. So we can do calculations and we can use the sensor data in if statements as well, right? So the sensors allow a device to be controlled in two ways. It means with using a sensor, the device can, like if we have given a program to work according to the sensor data, this can work. So this is called preset program. Or else we can get the sensor data into our mobile phone. If we connect our mobile phone to microbit, we can get the sensor data and we can do anything with our mobile phone. Like that, these are the two ways that sensors allow device to be controlled. It means with these two ways we can control some device with the use of sensors. Right. Here, so when we now at the end of the lesson we are going to plan a smart solution. So that's why we have learned about this microbit and the sensors, all the things, right? So before doing the program in make code or MicroPython, anything, we have to first draw a flowchart like this. Here like this, we have to first draw a flowchart and then convert to blocks and the code, right? If you can directly convert the flowchart into MicroPython code, that's also okay, right? So the flowchart help us to plan the program logic, right? And when we compare the sensor data, you will see how we compare sensor data. We have to use these comparison operators. We have learned those comparison operators in our flowchart lesson, right? So let's say we are comparing if the light level, if we use a light sensor, we can measure the light level in the environment. It is varying from 0 to like 255 rays. So here we can see if the light level is less than 128. So if yes, it means it's dark, right? It means it's dark in the room, so we can turn the light on. If yes, turn the light on, and if not, turn the light off, right? So we can use the if statement here, and also else for the no part. If and then the yes part, and else the no part, right? So here the changing comparison operators can change the program's behavior. So this is the main thing in this algorithm. When we draw a flowchart, the comparing the sensor data is the most important part. So if we mistakenly put this operator like this is less than, or if we put greater than here, the whole program will work, but there's no point, right? So if we like use the greater than sign here, so if light level is greater than 122, then the lights will be on. So there's no point now. If we have light, then we don't have another lights on, no? Like that. We have to carefully use these operators when we do programs with these sensors and microbit boards. So flowcharts help ensure the program's logic, right? And also, let's say we have to display happy face. Here we have to type the happy in capital letters. That is a rule in MicroPython. So we have to follow the syntax properly. So those are like errors. Those are the errors that can happen in programming in this micro bit. So using flowcharts, we can avoid it. Right. Here, planning a smart solution. Here, this is about the light level thing. Let's say we are planning a smart home blinds control. It means in the home, we have blinds like curtains, right? So if the light is like if the daylight is in there, like it means that we have we have a sufficient amount of sunlight, we can open the blinds to get the light into our room. Like that, start and if light level is less than 122, it means that there's no sunlight, so we can close the blinds. Otherwise, if there are lights, if there are sunlight in outside, it means the light level is greater than this sun, so this becomes false and we can open the blinds like that. Here the light level means the sensor value. When we use a sensor in the microbit, I told you the sensor data is converted to integers, and we can store this inside a variable like this, and then we can compare. Here also, if we see a smart home temperature control, here let's say we have a heater. in Sri Lanka, normally we don't have heaters, but if like the upcountry sites, they have heaters. Like Nuvareliya, Matale, they have heaters because most of the time it's cold there. So let's say we are doing a program, a smart solution to check if the temperature is low. It means if it is cold, and then only we can turn on the heater. If not, we can turn off the heater. Like we can reduce the waste of the energy, like that. We can, this is a good program if we can develop this one. So here also in the flow chart, we have to write start, and we are checking if the temperature is less than 18 degrees. If the temperature is less than 18 degrees, normally it means it's cold. So we have to turn on the heater. And if not, we can turn off the heater. Right? So tell me if you are clear up to this point.
Yes, miss.
Yes, miss.
Clear?
Yes, miss.
Yes, miss.
Good. Okay, then now we know how to plan a smart solution. First, we have to draw a flow chart and ensure the programming logic here. The logic is correct. Ensure our logic is correct. Right? We have to pay a lot of attention to the comparison operator here, because if it goes wrong, our whole program will work will be useless, right? So here we can test the programs. After we draw flowchart, we can test our program, right? We can test our program. Even after we do the program in make code and do the program in MicroPython and send the code to the microbit, and we can test it with the actual device as well. Here testing can happen in any phase, but we must test the program before we are using it. Before we actually use the program, we have to test that. Right here, let's say if we test the program, we can have a test plan like this. Let's say we are testing this one. We can have test numbers, and we can enter various temperature data, and we can here write the expected outcome and see if it actually works with the actual outcome. And if these two match, we can tell our test case is pass, right? So here let's say a temperature is 15 Celsius, so it is less than 18, so we have to turn on the heater. That is the expected outcome. Here, if our program is correct in actual microbit board, our outcome will be heater turns on, right? So the test case is pass. We can't do this with the microbit board. We have to like connect the heater to it, like that. We have to do something, but the basic logic is inside the MicroPython, right? So the algorithm tracing is also it's a technique we can test. We can do testing. We can trace the algorithm here like that. Or now we are starting and checking like that. We can go by the steps in the flowchart and check if there's any error. So this is a test plan. And this is the last topic. It's about project planning. It means when we designing a smart solution or smart home system, we have to follow a project plan. There are several steps. First one is planning. It means we have to decompose the problem. Decompose means we are making the problem into small categories, and we can decide what we are going to do. This is the planning. And designing means doing the flow charts and design how it will work. And create means actually writing the code. Testing means this one. Here we test the code and then we have to evaluate. Evaluate means we can see how the program test results work and see if there are any errors, like that. This is the final phase. And during the planning stage, we have to consider who will use the program and how easy it will be for them to use. If we are planning a solution, let's say for a person who want to use a smart home, so we have to consider how easy our program is to use. That means usability. Usability means how easy to use. It means the user friendliness to our program, right? So if our program is usable and it is user friendly, then it's good. So we have to consider who are going to use that. Let's say if our program is going to be used by all person, right? All person. So we have to consider some facts like that's actually a big topic, but just have the idea. We have to plan our project with these 5 steps, and our project should be usable, right? So that is the end of lesson. So if you have not typed your names into the chat, please type your name and class, right? Then you can leave. I will share the recording and note later.
Excuse me, miss.
Yes.
Is the class over?
Yes, Dali. Here you have asked a question. I missed since the 2-1 is 18 Celsius.
It says like it's less than 18 Celsius. So that day in school you told even if the number, if it doesn't have the equal mark, we can take it.
Yes.
Is the class over?
Yeah. You can type your name and leave. And I will share the note. And if you have any more questions, let's discuss at school, right?
So the class is over, right?
Yeah. Goodbye, everyone.
Bye, miss.
Bye, miss.
Miss, is the class over?
Yes, yes.
Bye.
Yes. Putang